Hi all. In this video, I am going to present a paper titled Deformable Data. So this paper has three main components. The first one is transformer neural network architecture, and the second one is building an object detections based on transformer neural network architecture called data. And third one is improving the vanilla data by the concept from the deformable convolutional neural network paper, and improvising that concept into a data and formulating a different architecture called deformable data. So we will be seeing one by one now. So we'll go directly to the third sections, which describes one by one. And the first one is transformable transformers. Transformer is like it is an improved version of this for sequence to sequence modeling, where for NLP task, they put up a neural network architecture called neural machine translations, where it has an encoder decoder mechanism based on RNN. Later, they improved with the attention mechanism, which giving a weightage for different representations from the encoder to get a to train the decoder to put an attention on different components from the encoder. So where this A1 are attention weights, which are learnable from the simple linear network. Now later they introduced an architecture, like we all know that it's a transformer neural network architecture, which also has tries to predict the sequence to sequence modeling, completely taking out the RNN structures in encoder and decoder mechanism, and putting only based on the attention mechanism. So attention mechanism is what put up in this encoder mechanism. Attention mechanism was put up in this decoder mechanism, and they try to embed the input sequence and try to predict the output sequence. So this is what a setup. The main contributions from this architecture is they completely remove the recurrence things and purely based on self attention and cross attention layers, attention mechanism. They try to try to formulate a sequence to sequence modeling task. So what is attention mechanism? So this is what attention mechanism is about. It has so this explanation is given nicely here. So what and a pictorial representation is given in this paper nicely. So what does attention mechanism is for a given input features, say X. So those input features, based on this input feature, three things are being computed. One is query, key, and corresponding value. So based on how this relations between the key and the query is been formulated through this attention through this dot product values. Based on this things, this weight that weighted this value vectors have different values, and those will be taken as a weighted average to compute the output. So how much weight it has to take for different elements has to be determined through the cross relations between the query and the key values, and it is normalized. So this query, key, and the value matrices are being formulated from the input features based on linear projections, which are learnable matrices. So this is for a query matrix, this is for a key matrix, and this for the value matrix. And all these matrices are trainable parametric matrices. Through this query, key, and value matrices are formulated, and the corresponding output can be computed from the weighted average of those values based on the cross relation between the query and the key. So if this only if it is only a single attention per layer, then it has a very limited capacity. So to increase the model's large capacity, we have a multi-head attentions for every layer. It is nothing but the extension of this extension of these equations for different heads. So we have like n heads. and every head will have query matrices, key matrices, and value matrices, and this formulation is formed for every head, and we will all those informations will be concatenated into a single vector, and then again it will be projected into a original dimensions, and that projection matrices is also a learnable projection matrices. This is what a multi-head self-attention mechanism. So what query, what key, and what value is what differing self-attention and the cross-attentions. For encoder mechanism, we have only the self-attentions, which will be and the query, key, and value all will be based on the input features. In the decoder, we have two attention mechanism. One is self attention and the cross attention. For self attentions, it will be based on the object queries, and for cross attentions, it will be based on the query will be based on the object queries, and the key values will be based on the output of the encoder mechanism. So we'll go back to the original paper. So this is what they described here. So, and those what I described about that attention mechanism with multi-head is been put up in a nice format in a single equations. So this is what the features is a self-attention mechanism, and this is what value learnable matrices, and this is what attention values, which itself is been given in this way here. So this is what a cross product, and it's normalized, and this gives you like kind of a weighted average for computing those from the value matrices. And for different head, so we'll have a different attention values, and then all those things will be concatenated and it will be projected by this projection matrix. So this vanilla transformer neural network architecture has two potential issues when we are applying to the image domain. One of two things is one is, so the image domain has a very long key and query data. This is nk is the number of dimension of the key and query. Nk and nq are same. So this is very large because it will be based on the pixel based features. So if that would be very large, then this will be uniformly initialized with some kind of 1 by nk value, where the attention has to be developed for each head in each layer will be a very cumbersome. So what attention has to be made for different key elements would be learnable, will take a very enormous number of training time in order to converge those into a true attention mechanisms. And the second thing is computational complexity. When nk is becoming very large, then these are the cross attention, these are the important order of computational complexity per head, and especially this is the dimension of the input feature. This is this when nk and dimension of the each input value, and when the number of features is nk and nq and nk is almost same, becoming very large, then it will, for per pixel, it is going to be the complexity of n square operations, so which is really very large in terms of a high resolution image data. For that, people try to put in raw solutions and try to use that data, which again it has and the training complexity is very tedious, and then the convergence is very slow. So this is what transformer neural network architecture, and it's put into the image domain. This is the limitation it has. Now we'll coming up in how we put up the transformer neural network encoder decoder mechanism for the image object detections. So for object detections, the paper what we they introduced earlier was related to this. They have the encoder decoder mechanism. The image, the high large resolution image will be given to the convolutional layers. That convolutional layers output would be taken as a feature input, which can act as a queries and key values and key and values for the encoder. And cross attention, there will be an object queries, and these object queries and this output from this query value will be put it in the cross attention mechanism. For self attention, this object query itself will be sufficient to generate the key and query values. So, so for this sequence to sequence modeling task, putting object direction as a sequence to sequence modeling task. This is what the structure what they produce in the data. But unfortunately, for large resolutions I mentioned earlier, this everything will be act like a pixel-wise manner, so that the sequence length will be enormously large, and developing proper initialization is very cumbersome. And if you make an uniform Gaussian distributions of zero mean and unit variance, then it will take a very large amount of training time and optimization technique for this attention mechanism at every layer, at every head, in both encoder and decoder mechanism to get converge properly. So that's what they have mentioned in this things, in all those things. So even though the object queries of order of dimension 100, but if the image size is going to be a very large resolution, horizontal and vertical resolutions, then NK and NQ is going to be very large, and in that aspect, computational there will be overhead of computational time, and also there will be also the convergence related to the attention mechanism. So this is where deformable transformers come into play to address the limitations that what we have while applying uh, data for high resolutions object detections. So what it does is it takes the inspirations from deformable convolutions, which was introduced in this paper. What it does is, if the convolutional architecture will have a regular grid, and it tries to address at each and every window, which will take a large number of operations. Instead of that, they will make an learnable offset with weight matrices, which can distribute these 9 points into a different scales and different directions, so that we can those weight information can be captured in all along uniform directions. So this same setup is been adapted in this one. They put up like every point, they try to take only k number of attention points to be taken into account for each head, not like uniformly sampling from all the elements. Only they take the k elements. What k elements has to be taken to be addressed at every point is been learnable from this setup, so that for m attention heads, only the k elements per head is being learnable, instead of taking an nq attention heads. So this is what a fundamental concept become on the deformable data. So instead of going for a very large space of weighted average, they take only sampled keys, selectable search, like k can be order of 100 or less than that, and through that, for every point, those things are put into weighted average and taken into an attention mechanism to compute the output. So this is what this paper is about. And additionally, they have auxiliarily they added like a multi-scale pyramid of input features, which gets a pyramid of features from the encoders, and that pyramid of encoder features can be utilized in the cross attention mechanism in the decoder mechanism, which gives an improved results compared to the single scale image resolutions input to the encoder decoder mechanism. So this is what they took like four resolution, and this is what could be the query and key, and what are the things has been added, and they put this cross multi resolutions only for the cross attention, not for the self attention in the decoder mechanism. That's what they have mentioned in the paper. So hopefully we'll come up with the next paper related to the data, possibly dynamic. Possibly we can take the paper like. This is what denoising data, and this is also another paper where they try to make learnable queries into putting an learnable anchor box as object queries inside the decoder mechanisms, which it's called as dynamic anchor box data. So hopefully, if we have a time in future, we will put up a video on this two papers in a single video. Thank you.